Hello! Today is Tuesday, February 9th, 2021, and this is going to be our game dev stream. Let me just double check that Twitch is not lying to me, that I'm actually streaming. It does like to do that every once in a while. I also make sure everything's in the right category. Yes, okay, everything appears correct. That is good. Alright, so today is going to be the game dev stream. Or not today, right now is going to be the game dev stream. It's going to go for roughly 2 hours, and then I will take 1 hour break, and then we will come back for 2 hours of some Valheim. Anyway, let me get the actual camera turned on. I believe I'm using this one. Yes. Okay. Oh, does my face need to appear there? No. Has it always been there? Okay. No, I want it over here. This is the wrong, you know, it doesn't matter. Who cares? It really doesn't matter. Anyway, we have been working on the racing stuff for the past week or so. A little over a week. Yeah, but today I'm going to switch to something different. I'm going to call the racing stuff sort of done. It's not really, but I'm going to call it done, because I am a little bit tired of working on it and I just can't get the physics to work out right. I think I've spent maybe 20-ish hours working with the physics and I just can't make it do what I want. So I'm going to just pretend that it's done and not get hung up on it. So the game that I want to make today, and not today, but over the next week or so, is a game that I made for a game jam once before. Basically, the way that it works is you have a solar system, and my hair is messed up. You have a solar system, and you have a bunch of ships that you command, and the ships basically are, each one is tied to a planet, and there's like waves of incoming enemies, and you have to defend the planets from the enemies, and yeah, it's sort of a wave defense kind of game set in a solar system. So we're going to work on that today. I think the first thing we're going to do is get sort of the solar system itself set up, and then the first thing we're going to do is get the solar system set up, the camera sort of navigating around it, and then maybe we'll work on the ships and stuff like that. So the first thing we will probably need is to define the center of it. We'll say solar system, create a game object that represents the solar system. Sure, that'll work. And then let's create a planet, or 10. So that will be, obviously, a sphere. That's how most planets are shaped. Actually, technically, planets aren't exact spheres. They're actually, like, thicker around the, like, midpoint, like the center, or, like, the equator of the planet. They're actually thicker. They're, like, kind of collapsed, but, you don't notice. Oh, that's, no. Cappy, don't do that. We do want the planets eventually to rotate sort of on an axis. So I'm going to do the thing where I have a game object that surrounds the sphere itself. So the sphere will be the model of the planet. And I do want to remove the collider from here. I actually want it on the planet itself, because I want all of the collision stuff to go on just on the planet itself. So the next thing we need is probably a material. We'll put we'll say temporary, and hopefully that doesn't become the permanent folder. So yeah, this material will be planet 1, sure. Just have that be a nice sort of brown color. I mean, that's fine. That's fine. It'll just be temporary. Yeah, sure. And then we want this to rotate at some distance from the sun, which we should probably create. Probably duplicate this, call this let's say a sun. It should be a little bit larger than the planets themselves. Maybe 2, 2, 2? 5, 5, 5. 5, 5. Yeah, that'll work. And eventually we will spawn the sun in dynamically, but now we will just keep it like this. 1. Call that material sun 1. This will be a nice yellow star. We could eventually have different kinds of suns, but this one will be like this for now. I don't know if we want collision on these, so I'm going to set those to be, the colliders are going to be triggers. I'm just trying to think of how we want all of this to work. So I think actually I want this to be a certain distance from the sun, right? Let's make them orbit. Should also have a prefabs folder. And I will just turn these two into prefabs really quickly. This will be the sun, this will be a planet. And let's create a couple of them. Maybe have them be different sizes, I don't know, that can be a gas giant or something. Because that's roughly how big a gas giant would, well no, I think it'd actually be far larger, but it doesn't matter. We have another planet like right there. I think the way that I did this originally was I had them like, they would measure their distance from the origin, and that would be their sort of orbit. Say planet, call them all the same thing, that's fine. And yeah. But anyway, let us make a orbit script or something. A folder, we'll have planet, we'll have components. Yeah. And then we'll have, I don't know, orbit component. Orbit component. That'll make it orbit. Or, you know, sort of orbit, not really. It won't be like a real orbit, but, you know, it'll be close enough. We might make it a real orbit later. Of course, the camera's freaking out. For whatever reason, the lighting is just never constant in this room. I become invisible, yes. Let's bump that up a little bit. Nope. Nope, nope, nope. Will that fix it? Wow, that actually works quite well. I'm happy with that. Okay, so let's get rid of that. So to make these planets orbit, I believe what we need to do is we need to set their position based on the sine and cosine of the current time or something. Is the current time, or is it? It needs to be based on the current time, I believe. So that's going to be something we do in the update. So this will be the private void update method. It doesn't have to be private, but I like to make it private just to remind myself of how Unity works and how it's kind of weird. We will say the transform dot position is equal to, or actually we'll just say, no. Yeah, we'll say var position equals new vector 3, and we're going to want to change the x and the y axes. We'll get rid of this later, or we'll fix that later, actually. Position equals position, yeah. And so we're gonna want to change, no, sorry, the x and the z axis, yes. So I can't remember which one is which. Oh no, cosine is x, sine is y, or sine is z. Yes, that's how that works. So it's going to be equal to the, oh god, stop, I don't care. It's going to be mathf dot sine of, I believe it's time.time, and that will cause it to orbit, I believe, at a relatively quick speed. Actually, this needs to go down to cosine. Cosine needs to be here, time.time. And then the position is going to be equivalent to whatever the current position is. Or actually, no. Yes. Position dot y. So basically, this is the x, and in 3D axes, this is the x and this is the y. So sine actually gets mapped to the z-axis in a 3D sort of setting, just because that's how Unity works. And then I think we need to scale this, is that right? Oh, how does it work? It's the like orbit radius. So the protected float radius, or no, public float. I think we can say don't, or hide in inspector. Yeah, hide in inspector. Basically, we want to set this radius based on where the planet is at the beginning of the game, or when the scene is loaded, I should say. So on awake, what we're going to do is we're going to say that the radius is equal to the transform.position.z. So things will be, or planets will be spread out across the z-axis, and that will determine the radius of the orbit. So we're going to multiply the sine and cosine, so this will give us the position on the circle. But what we need to do is we need to say the radius times the cosine and the radius times the sine. That will give us a circle whose radius is equal to, or that will give us a position on a circle whose radius is equal to our orbit radius. And I believe these will rotate, or these will orbit incredibly fast. So I'm going to say public float speed. It's always fun. That should be equal to 1 at least. And I believe this needs to be, it is speed times time. I believe it's speed times time times mathf.pi. .pi? Yeah, something like that. And basically this will give us should give us a rotation every 2 seconds at 1. I think that's how that works. Because a full circle should be 2 pi in degrees, or in, yeah, it should be 2 pi in, yeah, 2 pi degree, oh god, I don't know how it works. It should be 2 pi in circumference or something. I think that, no, it's pi in circumference, 2 pi in degrees, or something weird like that. Anyway, this should work, is what I'm trying to say. And if it doesn't, we need to do something else. So let's go to our planet prefab, go to the orbit component, put that on there, and let's see what happens. Whoops, let's not maximize. I did see them fly around the screen there. I assume they're orbiting. Whoops. Alright. Yeah, okay, so they're orbiting. They're orbiting the way that I don't want them to. Are they getting closer to each other? Going very quickly. Yeah, I think they're going in a complete circle. We can find that out by doing that. I think they're going in a perfect circle. It actually looks like they're getting closer down there, but that's fine. Unknown mono behavior is missing. That's fine. That can go away. All of that's fine. Okay. So we do have that rotating. That's good. And we probably want to set the speed on these to be 0.05 or something. And yeah, we'll have to be minus 0.05. That way they should go in reverse, and they should go roughly the way we want. Yeah, something like that. I kind of like that. They should be all a little different. I think don't the inner ones rotate faster or something? I think that's how that works. So say 0.08 and maybe 0.0, what those in order? 0.03? I believe that's how that works. I wish the camera would stop doing that. But yeah, now they orbit a little bit differently. Maybe that's too slow. I don't know. I think it's fine. We'll figure it out. So yeah. The next thing I think I want is a sort of trail kind of thing to show where they're going to orbit. I do want that to be a little further out, actually. Yeah, that'll work better. And then that to be like that, and maybe that to be there. Kind of just want the distance between the planet and the sun to be a little bit different. Yeah, that distance and that distance should be different from that distance. Okay. That's fair. And then each planet will generate a sort of little trail around it. And I want that to be done with a line renderer. So we're going to go over to prefabs here in the planet. We're going to add, I believe, a line renderer, or a sort of trail. Actually, how are we going to do that? Because the planet is up at the top. We actually want the trail to be generated. We don't want it attached to this object, or do we? Well, the problem is we want it independent of the planet itself. So no, we don't want it generated here. I would prefer it be generated at the top level. So let's create an empty and say or orbit. Call this an orbit indicator, or orbit path is what we'll call it. And we'll create a new 3D line renderer. How does that work? Where is that? It's in effect a line renderer? Yes, okay. So I believe the line renderer, we can edit, where is it? Ah, right, we can add segments to it. Can, I believe, move the segments in 3D space? Yeah, you can move the segments in 3D space. You can add them, etc., etc. So I don't know what that looks like in the actual game itself. Oh yeah, we can see that. Alright. Now what material should this use? It should not be using a particle material, I know that. We'll use a default line for now. That'll be fine, yeah. So the actual segments shouldn't matter right now. Have the orbit path be at 0, 0, 0. And this, can we remove these? Delete? No? Okay. So I think it requires at least 2 or something like that, but it doesn't matter where they actually are. Those can be at 0. Yeah, it can be at 0, 0. It's fine. It's going to be created dynamically anyway. So I think that should be a component, say an orbit trail component, orbit trail component. This should reload the assembly, right? Yeah, orbit trail component, yeah, okay. And so this is going to have just a single method on it called setup, and it's just going to set up the orbit trail. It's going to be a public void setup, and we're going to have a float radius, and that should be really lowercase. So this is going to have a public, I think it's a line renderer, yes. And this is going to be the line renderer. And so what we're going to do is we are going to create a number of points. Say var points is equal to, let's say the base is going to be 30 and it's going to be times the radius. Wait, no. What would we say a good, like, sort of default radius is? We're going to say maybe, we'll just say 1. It'll be 30 times whatever the radius is. So if it's got a radius of, say, 10, we'll have 300 points. I don't like that. That's a little bit much. Actually, what are the radius? What do the radii look like right now? So that one is at 4. That one is at 10. So we'll say minimum of 30 times the radius divided by, or 30 plus 10 times the radius. So the minimum is 30 points, and I'll say minimum of 20. So that'll be the points. Basically, the line renderer, I think you just set the actual points, so you say set positions. So this is an array of vector 3, so this sets the positions of all the vertices, okay? So what that should mean is that in order to create the positions for the line renderer, what we need to do is we need to create an array of vector 3's, and then that is has a number of points equal to the number of points here. So I think that's going to be a no, not for each. It's going to be a 4int point equals 0, point less than points, or no, index. Say index equals 0, index less than points, index plus plus. Oops. Yeah. Oh, do I not have, hang on. No, I do, okay. Alright, so for each, so for the index, so at the index, the point, okay, we need to actually have a var positions equals new list, so that is from system, so using system, I think it's system.collections.generic, .collections.generic, yeah, there we go. So new list of, say, vector 3. The actual set positions method requires a array, but we will be able to convert this list to an array very easily. So we will say positions.add, and this will be a new vector 3. And the position will be some point along the orbit. And so it's just a matter of figuring out what point along the orbit that is. So if I remember, sine and cosine, they repeat every 2 pi. I believe that's how that works. So it will be mathf.pi times 2. That'll be a constant that we have. That will be times the, I believe, radius. Is that right? No, it's mathf.2pi divided by points. So this is the increment. So we'll say var increment. So the increment between each point is that. Why does it not like that? What is invalid about that expression? That is. All right. And we don't need all of this actually now that I think about it. We don't even need this. It's divided by points. So why is that considered a float? That's interesting. I don't like that. Should not be a float, that should be an int. Yeah, there we go. So this is the increments. This is each little piece of the circle. And so it's the increment, the cosine of that. It's mathf.cosine of each little increment length. That times the radius should be the position. And then it should be transform.position.y, and then this will be sine. And now that we've got that, we just add that to positions, and then what we do is we will have a, what's it called? We do line renderer, no, not line alignment, line renderer dot set positions to be positions, dot to array. And then what I want to do is, well, actually, let's test this first, then I'll optimize this away, because I think we can. So what we want is we want this orbit path to be a prefab, right? I'm going to delete this. And then what we will do is in the orbit component, we will reference that. So we'll have a public orbit path or orbit trail component. Let's call that an orbit path component. Orbit path. It's not really a trail, it's a path. Let's put that there, and then an orbit path component. Say path, or say orbit path prefab. And so on awake, what we will do is we will create a new one, a new orbit path prefab. So we'll say var path is equal to instantiate path orbit path prefab, and we will spawn that at at vector3.0 with a rotation of quaternion.identity, which is basically 0. And then we will say path dot setup, and then that will be with our radius. So this should create a path with our radius on it. And then after we do the setup, we want to remove this. So we say destroy this, because there's no reason to have it kicking around after it does its thing. So, yep, and in here we'll have the orbit path component. Then in here we will set the line into here. All right, and then for planet, the orbit path prefab will be that. And let's see what happens. So, looks like we got a bunch of orbit paths. None of which actually worked, it looks like. We can edit. Oh, interesting. Okay. Maybe I'm wrong. Maybe it did. No. It looks like they all got created there. Edit. Can I go into debug here and see what those positions actually are? It's line renderer, the positions. There's only 2 of them. Why did that happen? Because the points should be... Okay, that's very strange. Alright, let's take a look at this. So we'll say, no, not destroy. We'll say debug, not log error, just log. We will say points plus points. And we will say setting positions, and then we will say the positions dot count. All right, so we should get setting positions 3 times, and we should get points printed out 3 times. So let's just double check that that actually works. That's correct. So it looks like there are 237 positions on some of these. 67, okay. So the question being, why are there only 2 here? There are only 2 here. There are only 2 here. Why? That's very weird. So line renderer dot. What can we do with this? Wait. Wait a minute. Line renderer dot. Is there something else we need to do to this to make this actually work? Or am I crazy? Get positions, get materials, hide flags, instantiate is visible. Loop.name. Reference equals, set colors, set positions. Set the positions. Oh, do we have to set the vertex count? Is that what we have to do? No, we have to set something, don't we? Set that, set position, set vertex count. Do we just say vertex count? Number of corner. Let's check this out. Line renderer, set positions. Okay. So this method is preferred to set positions, setting all positions more efficient. Note that position count must be called before set positions. That's what it is. There we go. Is equal to 2 points. And then we can rename this to position count. All right, and so we can set that as early as possible. Actually, no, let's not. Let's set that here so the 2 are next to each other, so that we remember. Also, I think this scaling is a bit much. Cut that in half. That way it'll be 70 if the radius is 10, which should be fine. And let's see if that worked. Okay, I am not seeing the line renderer, but there are at least the correct number of positions. So where, let's see, let's go to normal. Where are the points? Are they all in that one place? I think they're all in that one place. I think that's true. I think they're all in that one place. Show the wireframe. Okay. It's not useful. Normal. Debug positions. So it's as if it's a constant. Did I forget to multiply by the index? Yes, of course I did. Times index. It's bound to forget something. So now that should generate a line, or a, not line, but a circle. Well, that's a funny looking circle. Okay. f dot cosine of increment times radius. Oh, it's increment times the index, isn't it? That's what it is. Trig was never my thing. I mean, I wasn't bad at it, but it's never my thing. Alright, there we go. Yeah, look at that. Snazzy. Alright, I don't know why that gap is there. I'll have to figure that out. Oh yeah, I do know why that gap is there, actually. Because we don't actually go to the last increment. We don't actually loop around. Okay, but yeah, I kind of like that. That is kind of cool. And as you can see, the planets kind of follow a orbital ring or an orbital path. What we need to do is we need to duplicate the first index. But before that, I actually want to get rid of most of this. So what we can do, I think it's IEnumerable dot, no, IEnumerator dot, oh, what is it? Is it enumerable? Enumerable dot, is that not a thing? C# generate list of numbers. Is that a thing? That's totally a thing you can do somehow. It's enumerable dot range. Yeah. C# enumerable import. Oh, it's from system.link, really? Alright, that's cool. So system.link. So what we can do is we can say enumerable.range from 0 to position count. You can say dot for each. Well, no, we want to do a map. Say dot map. Not map. We want to select. Want to select each index such that it is a new vector 3 of that nature, and say toList, and then for each of those, or actually no, we don't even need to do that. The positions are just equal to that. Then we say dot toArray, and then we have no need to actually convert this into an array. So basically that for loop was just replaced with this. And now what we need to do is we need to say positions. Nope. We need to say positions dot add. Oh right, we can't. That's annoying. Fine. Dot toList. Yeah, dot toList, and then what we will do is we will say positions dot add, positions dot get, positions of 0, sorry. Use the indexer. Basically what we're doing here is we are adding the 0th position, the first position, to the end. That way it will create a completed circle. And then here we actually need the toArray again. Yeah. So this should be functionally equivalent, and it should complete the circle, which it is, and it does not for some reason. Why does it not? Oh, because the position count needs to have one more added to it. Oops, nope. It will be, oh, we can't do that. Right. So it's position count plus 1 is what we need to do. And yeah, something like that. And that should work? Yes, that completes the circle. Okay. It's a little hacky, but it's not terrible. I'll live with it. Alright, so the next thing I want to do is create the sort of camera controller. So the original thing that I did, I had the camera, it would face, which way would it face? No. Yes. That's right. It faces right now the negative z-axis. Why does it face... Wait, why? I thought cameras face the positive z-axis. Am I crazy? Yeah, I am crazy, because it does face the positive z-axis. Oh, no, the local faces the positive z-axis. But this camera apparently was turned in some strange way. Alright. That's fine. So yeah, the z-axis should be forward. I like that, because otherwise we're going to get messed up. What I want is I want there to be a center for the camera. So this will be the camera. And then I want the camera to be centered on that object. And then that will be at 0, 0, 0. And the camera itself will be back a little bit. Actually, we want to tilt it first. So I want to tilt it probably about 30 degrees. And then we'll use the local here. Nope, I don't want it 30 degrees. I want it maybe more like 60 degrees, right? That's probably fine. Whoops. Pull the camera back this way a little bit. And it won't actually matter because we're going to switch this to an orthographic camera because I like the way that that effect looks. So this is going to be an ortho camera. And basically the size of the orthographic window is going to be like this. Maybe we'll have it be 7. It'll definitely be adjustable at some point. But yeah, I want this to be the camera. And so we're going to create a script. It's going to be a component. It's going to be a camera controller component. Camera controller component. And then this will just control the camera. So I think to start off, we're going to control the camera with physics, and maybe we'll change it later on. Or will we change it? Will we control it with physics? Actually, will we control it with physics? No, let's not. Let's just lerp to the position that we want to be at. No, wait, actually... No, let's control it with physics. Because we can always lerp it later. Yeah, so we'll have a public rigid body, which will control the camera. Rigid body. And then we'll, on the physics updates, this will be the private void fixed update. We will have the var, the direction will be a new vector3. The direction will be the input.getAxis. Whoops, nope. The getAxis, input.getAxis. And the y velocity will always be 0. So this will be the vertical axis, I believe. Yes, the vertical axis, because it would be the z. And then the no, it'll be the x-axis, so it's the horizontal axis. Horizontal, and this is a vertical, like that, and this will be the public float speed, and that should be at the very least 1.0, and then the rigid body dot velocity is going to be equal to the direction times the speed, and we will just normalize that so that it's always a constant speed, or a constant sort of velocity. And I think that will work. Yeah, let's try that. So let's go to the prefabs. Let's go to our camera prefab. Let's add a rigid body. It will have no gravity. Then we're going to add a camera controller component, which will be this. We will go to that rigid body, and let's see what happens. So our camera's are pointing in an okay place. Yep, I kind of like that. We just need to adjust the speed, say, I don't know, 5. Why is our camera moving so slowly? Did I not multiply by the speed? I thought I multiplied. Oh, because I normalized it. I normalized it at the wrong place. That's the problem. Its direction. The direction is this dot normalized, and then we want the direction times the speed. That's our velocity. Yes. Otherwise, we were normalizing it after the fact, which we don't want to do. And this can probably be like 3 or something. And it should move much faster now. Yep. Okay. And by 3, I think I meant 7. Yeah, here we go. That's roughly about right. Well, we'll probably need it to be a little bit faster, but it's okay for now. Do I like that? I think I actually might want the angle to be a little bit steeper. Yeah, I kind of like that. It's rotating so slowly. Okay, I think I'm okay with that. It has a weird kind of quality to it. That is because it has a 0 to it. All right, so I do kind of want it to. No, that'll be fine. We'll deal with it later. So the next thing I want to do is get the, I guess, spaceships part up and running. So let's think about how we're going to do that. So basically, the mechanics from the original game that I want to work with were that each planet could produce a certain number of spaceships. Well, it could produce a certain type and a certain number of spaceships. And each individual planet controlled the upgrades for its spaceship, so you could select the planet and upgrade all the ships from that planet. And then the spaceships, you could have them go out to various parts of the solar system to do various things. In this case, it was just defend. But I think in this one I want to do like resource gathering as well. So yeah, there was that, and then whenever the ships needed maintenance, like whenever they ran out of health or ammo or something, they would need to go back to the planet to repair themselves and rearm themselves. So yeah, I think the first thing we need to do is get something that moves around. So let's say we create a new game object at 0, 0, 0. I don't know why it has that very strange. Oh, okay, because our camera's not tilted right. Right, okay. That's what it is. Yeah, okay. We'll call this a spaceship. And then I want to move this out here just to work with for now. Whoops. Move this out here just to work with for now. We will create a new 3D object. This will be sort of the model for it. We're going to probably remove the collider. This will be the model. Will just be a little rectangle for now. So it'll be at 0.1, point 0.3. The Y maybe 0.2, and then that is 0.3, 0.2, 0.1. No, 0.5. Yeah, that'll be our little spaceship for now. We'll create a collider, say box collider. I mean, it won't really matter. Do I want it to be a box collider or do I want it to be a sphere? Actually, I think there's good reason to make it a sphere collider. Because this will just be the thing that determines whether or not you've clicked on it. And so I think clicking near it should give you sort of the same result as clicking directly on it. And so this will still be a trigger. And then we're going to add a rigid body, because we'll probably move the spaceships with physics. No reason not to, really. That's the only reason that we're doing that. So, I think that's fine. It just doesn't need to use gravity. Yeah, so let's create the spaceship component. new space ship. Let's call it a ship component. I think all of our ships will be in space. So yeah, we'll just call it a ship component. And let's get rid of all of this. I do need to look at something really quickly. Oh, okay, that's interesting. Nothing super important. We'll probably need to take a break in just a minute whenever I get this working. So the basic thing I want to do first is we want to click on a ship to select it, and then probably click somewhere else to deselect it. And I think that that's going to require stuff in the camera. I think that's how that'll work. Yeah, because we need the... So we probably need like a selection component. Control C, Control C, Control V. We'll say like selection control component. So what this will do is this will do a raycast to find a ship and try to select it for us. This will be the selection control component. We want this to be separated from the camera controller component because there's no reason that this should be connected to that in any way. And plus, it's also going to run in the normal update as opposed to the fixed update. And so what we will do is we will have a trying to think. What we'll say is if input.get mouse button down, we'll use the left click for now. What we will say is we will do a physics.raycast. Physics.raycast. And I think the ray is from the camera. No, God, I always forget how to do this. Let's think about this. Okay, physics.raycast. What we want to do is we want the origin and the direction. So it has something to do with camera.main. I think it's screen point to ray. Yeah, I think it's screen point to ray. And it's like the input.mouse position. And this should give you the ray. Then you raycast using the ray. And then we want the hit info. So this is the ray. And then we want the raycast hit. This is the hit. Yeah, just the hit. We're going to say out hit. So this out keyword, basically what that does in C# is you give it an empty variable and it says I'm going to overwrite whatever this variable is with what I with something from this method. And the reason for doing that is this method, this physics.raycast method basically needs to return multiple values. It needs to return whether or not the ray hit, and it also needs to return the actual hit info. And so what we say is if the physics.raycast hit is equal to that, and I believe what we can do is we can do out raycast hit like that. I think that's the correct syntax for it. Basically, I think this is a newer thing in C#. You basically don't need to declare these out variables outside of the method. You can actually do it inside of a scope like this. So we can say if hit dot other, or is it collider? It's collider, right? Hit.collider.gameObject. Actually, what we want to do, we want to say var ship equals hit.collider.gameObject. or no, it's not .image, it's .get component, yeah, because we can get it directly. Ship component. So basically this is the ship. If the ship exists, or if it doesn't exist, we just basically want to return for now, because that's all we're looking for. Or actually, no. I think we want to break, right? Want to break out of this? Is this actually valid? No, this is not valid here. I always forget. Can you use labels in C#? I always forget. Let's say we do I. Just I. This is a label, right? Yes. Break I. Does that work? It doesn't, because it has to be in closing. Yeah, okay, whatever. I don't care. If the ship exists, I hate this nested logic like this. It's so terrible. It's just so nasty. So if we have a ship, then we want to debug.log, we'll say selected or something. Selected ship, and then we'll call, I guess, ship.select. We'll say .select. And we don't have this method yet, but we can build it, or we can make it. Go to ship component, have public void select, and we'll just do a debug.log. Nope. Oh yeah, is this big enough? This should probably be a little bigger, right? I'll say ship was selected. So if I did that right, this should work. However, it's very likely that I did this wrong. Yeah, no, that's right. I'll say ship component on this. That's fine. And then on this camera, what we want to do on prefabs for camera is we want to add a selection controller component. Control component, yeah. And in theory, we should be able to select this ship now, right? So if we do that, okay, yeah, we get ship was selected, etc., etc. Yeah, perfect. I definitely need to fix this. It actually might just need to be on update. Not fixed update. Whatever. Figure it out later. So yeah, we selected the ship. What we want to do now is we want to actually add a layer mask to the ship, just in case it is behind something else. We really don't want to, we want to only be casting on the ship layer. So actually this will be the selectable layer. And so ship will be on the selectable layer. Nope, only change this object. So now, this requires us to change this a little bit. Let's see here. Should be able to do, yeah, okay, we'll use this overload. So the max distance will be mathf.infinity, and the layer mask. So the, actually, let's make a new folder for this. Yeah, we'll call this constant. And this will be a new, nope, Control C, Control V. This will be a game constant. This will use the dreaded singleton pattern, which I hate, but I have no real choice. It really annoys me. But yeah, what we will say is we'll say, yeah, public game constants instance. We'll have a get and set for that. So we'll say get, have a private version of it. We'll have it protected, sorry. Protected game constants. It'll be protected static game constant. Constants instance. Get, we will have a method called public, or no, protected void create won't even do that in a method. It's not necessary. So the get will say if instance is null, and we will say game or instance equals new game constants, and return instance, and that's all we will have. So yeah, that is a private setter. Where does the semicolon go on that? It doesn't go there. Actually, that's fine. So you can only get it, you can't actually set it. And so for this, after we have the instance, we will have a public int, a public read-only int, and this will be the, or no, an internal class actually. A public class, and we'll say layers. I don't know if nested classes work the same way in C#. Let's assume they do. And this will be a public int selection, or this will be selectable. This will be new, or no, this will be layer mask. No, we need Unity Engine. Unity Engine. This will be layer mask dot get mask for selectable. All right. So what this should do, they should be able to say game constants dot instance, right? This needs to be a public static game constants dot instance dot so it doesn't work the same way. That's sad. Let's say nested. No. Inner. Is that a keyword here? No. No, it doesn't work that way. Okay. Well, I tried. So yeah. Say public read only int selectable. Say layer. Yeah, select. Say layer selectable. Yeah, I don't know how you do. I don't know how you do like a forced creation of an inner class in this. I don't know how you do that. I don't care enough to figure it out. So b.instance.layerSelectable. I think you'd have to make an instance of the inner class, or maybe make it static, maybe. Yeah, I think you do. I think I'd have to do something like public class layers, and then I'd have to do like public layers equals new layers or something. New layers, something like that. I don't know. That's lame to me. Let me see if static does it. Yeah, you can make it static. What I was hoping for is I was hoping for the way that Java will let you do it. So if you do it, if you do something like this in Java, whenever you create an instance of game constants, you would actually get an instance of layers for free, and you could reference it in sort of a static kind of way. But in this you can't, unfortunately. And so I don't want to go through the whole trouble of creating another singleton instance of that, unfortunately. Yeah. I just wanted it because it's nicer to type. What I wanted to do is I wanted to do .instance.layers.selectable, so that it just looks. You can basically like create a namespace for variables inside of a class doing that. It's a really hacky thing to do, and you shouldn't do it, but I like doing it anyway because it's nicer to type and it doesn't have this prepended layer nonsense. But yeah, I have to do it. So basically the reason that I'm doing all of this is because this is not runtime constant, so I can't actually make it like a static read-only kind of thing. It's not, or sorry, it's not compile time constant. It only works, you can only do it after Unity Engine has been booted up. So in order to create like a global reference to it like this, I have to use a singleton, which I don't like, but I kind of have to do anyway. So yeah, that was a very long-winded way of basically creating a version of this where it has to be selectable, or it has to be, we only select things on the selectable layer. So let me create another version of this, and we will give it a different material so that I can actually test this. And so that's on the default layer. No, only this object. So if I did that right, and if I know what I'm talking about, the gray ship should be selectable and the yellow one should not. If I did that right. So if we click the gray one, yeah, we get the selected thing, and if we click the yellow one, we don't. Okay, that's what I wanted. All right, perfect. And basically, even if the gray ship is obstructed, we should still be able to kind of reach through and grab it. So if I obstruct it, so if I, okay, it's not obstructed in the right way. We'll move this over here. And at some point, nope. Right, this has to be like exact, doesn't it? Because of the way I did this. Let's move that there. Is that obstructing it? Not quite. Oops. It's obstructed a little bit. Okay. So we should be able to, okay, we can't. It's not what I wanted. Oh, wait, there it was. Yeah. If I clicked right on it, wherever it might be, there it is. It sits down here, yeah. Okay, so we can click through this because it's not on the selectable layer. That's what I wanted. All right. So, with that, my brain is kind of melting, and so I'm going to take a little bit of a 5-minute break. I will see you guys in just a minute. Alright, and after that riveting rendition of John Cage's 4 minutes and 33 seconds, we are back. That is not the right thing. That is neither the right thing. That is the right thing. No, that isn't right. That is right. Okay. I always forget. Okay. So, the next thing I want to do is I want to do two things. Well, more than two, but today I think we're going to get to two of them. So the first thing is I want to indicate which ship is selected, and also if the raycast fails, it needs to deselect whatever was previously selected. So basically whenever you click on something, you select it. Whenever you click off of it, you deselect it. Or if you click on something that hasn't already been selected. So with that, we actually need to we need to lift some stuff up, basically. We need to do some abstraction. So the first thing we need to do, I believe interfaces work with mono behaviors, but I want to double check that because I want to say that they do, but I just don't remember. Let's see. The first thing I want to do is I want to move this select method into an interface and call it selectable. So this should be selectable. Oh, they do? Okay. That's good to know. Because I can never remember if the get component, what I can't remember is if get component searches for interfaces in, like, if a mono behavior extends an interface, does the get component called from that interface, oh, this is not what I wanted to do at all. Does that work, is what I'm trying to find out. Actually, wait a minute. Okay, so yeah, since I copy-pasted this is fine. All right. So let's see. I just want to double check, because I thought it did, but I thought there was something weird with interfaces and mono behavior. Nope. I thought there was something weird with interfaces and mono behaviors. Like that. So if I said iSelectable, and then we inherit this, should be overridden. Actually, let me double check that it generates the warning. Yeah, it generates the warning, okay. And then we implement the interface. Okay, yeah, that'll work. And so if we say debug.log, not log error, just .log. And we say selected. Get rid of this, get rid of this. And then in the, what is it? The camera, no, it's not the camera, it's the selection control component. What I'm wondering is if I call iSelectable here, and then I rename this to selectable, if this works. I thought it did, but I also thought there was something weird. If selectable is not equal to null. Maybe I'm wrong. Maybe that was an old thing. God, I wish I could remember, but I just can't. Oh, so it does work. Okay, you're right. Yeah, I thought there was something weird with that. It's weird that it can't guarantee that this returns a component. Okay, yeah, you're correct. It does work. That's good to know. I had forgotten that, but yeah, I thought there's something weird with it. But I'm glad that that works because I didn't. Well, actually, I guess since selectable doesn't in any way relate to component, I guess it can't guarantee that. I guess that's fair. I can't remember if. God, I can't remember all the things. Okay, doesn't really matter. What we need now is we need a public selectable, which is the selected thing. And so if the selectable is equal or not equal to null, and and it's also not equal to what we've already selected. Then we actually want to call select. Otherwise, we don't want to worry about it because we don't want to select something that we've already selected. It doesn't make sense to do that. And I need to actually set that before that'll work. So say selected equals selectable. So we click this once, we get it once. Yep, we only get the message once. Okay, that's good to know. So what we will do is we will call that void, we'll say change selection. And we'll call this the iSelectable new selection. And so what we will do is we'll say change selection to selectable. Whoops, we will put this in here. Selected equals new selection and new selection dot select. Okay. And we'll call public void, create a new method, public void deselect. Deselect. Should that be? That shouldn't be capitalized. That should be capitalized. Yeah. And then we will call selected equals null. Say selected equals null, and we'll say selected dot deselect. Yeah, that's what we'll do. Just forward that call onto it. And then we should get an error in ship component in a second because it doesn't implement the interface. Yep. Okay. It's that, yeah. That to go away. I want this to go down here. Then we put this in here. All right. Say deselected. Deselected. Yes. Okay. And so otherwise, right. Okay. Actually, this needs to change. So we need to actually put this down here. Yeah, what we need to do is we need to change that. So if the selected is not equal to current selected, if we have something selected and the thing that we've just tried to select is not equal to what we have selected, then we change selection. Otherwise, we actually want to select something newly. Selection. I'm not entirely sure this is necessary, but I think whenever we do the UI, I think we'll want to know these different things because changing the selection might, well, actually, no, it shouldn't matter. Yeah, it actually shouldn't matter. Yeah, actually it shouldn't matter. Now that I think about it. So yeah, let's just put that there. So this should be change selection. I'm going to put parentheses around these because I know that C# can do some weird things with what's it called? The extension methods, and you can implicitly convert objects to Boolean, and that causes issues. So if the physics.raycast fails, then what we want to say is else else if we already have something selected, so if selected is not equal to null, then we want to deselect whatever we have selected. Yes, I think that should work. And I need a way to actually denote that. So what we'll do is we'll create a, call this a game object. This will be the selection prefab. And then we will create a public game object. This will be the selection indicator. Yeah, that'll work. And so on awake, we want to create a copy of the indicator. So the selection indicator will be equal to the, an instantiate call instantiate on the selection prefab. And we'll instantiate that at vector3.0 and quaternion.identity. I'm going to say the selection indicator dot set active. We'll set it to inactive. That way it'll be invisible. And on select, what we want to do. Ooh, but this will not be a game object. Okay. Ooh, that's interesting. Collider.getComponent. Okay. So we'll probably need a game object. Target or target, sure. It's not really what I want, but that'll be fine. So what we will do is we'll say, what is it? The selection indicator dot transform dot parent is equal to the target dot parent or dot transform, and then the selection indicator dot local or dot position dot transform dot position is equal to vector3.0, and then the selection indicator dot transform dot local scale is equal to vector3.1. Things can get weirdly rescaled whenever you do whenever you set their parent, so I don't want to mess with that. Actually, does transform have a set parent? I thought it did. It does. Is this the preferred way to do it? I can't remember. I think it is, right? Yeah, we'll do that. And then whenever we deselect things, what we want to do is we want to set the parent to null. This will move it out of wherever it was before. And then we can say selection indicator dot set active false. This will turn it invisible again. And we actually want to turn it visible here. So yeah, and the reason that we want to do that, okay, actually, problem is that we want to, okay, that's a problem. So my fear is that if whatever this is attached to gets destroyed, this will also get destroyed. So we'll have to do something about that. And we'll worry about it later. This will be the hit.collider.gameObject. Yeah, okay. So this should, I think this should work. So let's create a selection indicator. Let's just duplicate this, or actually no, let's not duplicate that. Let's delete this. Let's create a, under the ship, let's create a sphere. Sure. Let's make that, actually let's create an empty so that we can offset it, and yeah, let's create an empty so that we can offset it. Set the child to be that, and then we'll just have like the sphere appear a little bit below it. Be, I don't know, 0.5, 0.5, and 0.5. Now actually for the y it can be like 0.1, then it's kind of like a disk. Yeah, that'll work. And I don't know, 0.7 or something, 0.7, yeah, that'll work. Then we can remove the sphere collider because we'll never use it. This will be the selection indicator. Yep. This will be the model for it. And then now that we have that set up, we can unparent this. And then, yeah, we can put it into 0, 0, 0, and then we can turn it into a prefab. This is the selection indicator, and then we can remove it. And on the camera, on our camera prefab here, the selection prefab is going to be equal to this selection indicator here. So it should create a copy of that, and it should appear like we would expect. Okay. Where did it end up? It ended up at... No, where did it end up? Oh, it didn't get set to 0. Oh, did I set... Is it local position or something? Is it dot local position? Yeah, it's local position. Whoops. Aha, there we go. And yeah, okay. So now if I clone that, that should work. Alright, so I should be able to select these two independently. Yeah, there we go. You gotta change selection, and then I click off of it. Yeah, I like that. Okay. Alright, so the next thing we need to do is we need to make this into a prefab. Yep. Alright. I got through a lot of that much faster than I thought I would today. I thought this was going to take actually a lot longer. One thing we can do, I'm trying to think about what I want to do with the camera stuff. Not a huge fan of this. So one thing we can do is we can add scrolling to the camera. Just kind of a bonus thing to do, and then I'm going to kind of call it. We'll say public. Since this is the camera controller component, it probably should reference a camera. Camera. This will be the public float zoom level. Basically, just will make zooming in and out. And then on private void awake, the initial zoom level is going to be equal to the camera dot. Is it field? No, it's not field of view. It's the orthographic size. Yeah, it's the orthographic size. So in, not in fixed update, but in the normal update, what we will do is we'll say if input.get, is it get axis for the camera scroll? Oh god. Light is changing. Why is the light changing? It shouldn't be doing that. Oh, the public variables. So is there a reason for public variables instead of private ones? So I'm not sure how familiar you are with like Unity and whatnot. I'm making them public for a couple reasons. One of them is so that they will appear in the Unity inspector. So if I look at, let's say, this sort of planet here, this orbit script. So you see we have the speed and the orbit path prefab. If I go into, I think it's the orbit component, you see how the speed is public, and this one is, or this orbit path is public. If we create like a private variable, from what I recall, this will not appear in the inspector, if I recall correctly. This is broken because why? Oh yeah, that. Private fields can be shown. Oh, they can? Oh, it's, you need the inspector. Is it like show in inspector or no? How do you actually do it? From what I remember, it doesn't. Is there a way, is it like with debug or something? Oh yeah, debug will show it, but it won't let you adjust it. Is it like hide in inspector, the attribute, add the attribute serialized field, really? Will that really show that in the inspector? Well, that's cool. I didn't know about that. Okay, that's interesting. I wonder, that doesn't make, oh, I guess that makes, oh, force Unity to steer, oh, okay, I see. Okay, So that's one of the reasons, and then the other one is because that's good to know. Thank you for telling me about that. But yeah, the other reason too is that yeah, well, serialized field, yeah, okay, that's fair. But the other reason that I'm doing this is that I'm the only one working on this, and also I know which variables I'm supposed to change and which ones I'm not, and it just doesn't matter. It just doesn't matter all that much. Like, I agree with you, like, normally I would be crazy about it. Like, whenever I first started doing Unity, I was really crazy about public versus protected versus private and whatnot, but nowadays I've gotten to the point where I just don't care. It's bad practice, I know, but like with game development, so much stuff changes that what I found is that trying to adhere to like normal programming practices, it just slowed me down a lot more than it helped. But yeah, normally I'd be like all about that, like sort of private, protected, all that. In C# you can use protected a lot more often though, because it doesn't do the stupid thing that Java does. But yeah, that's why. And to anyone else who watches this, that's why. I know it probably drives some people crazy. So public float zoom speed. So the zoom level is going to be equal to the orthographic size. And so what we're going to say is if input.getAxis, I think it's like mouse wheel or something. It's like mouse wheel or something. I think it's like mouse scroll wheel is what it is in the axes. Oh god, where is it? Oh, so protected in Java. The difference between protected in Java, what it does is it's like package level protected. So basically, if you use protected in Java, things within the same package can still access it as if it's public. Whereas, like in C#, it doesn't work that way. At least I don't think it works that way. I think in C# it's only subclasses, right? If I remember. And then private is like only this class. But yeah, in Java, like you can access it. It's really stupid. If something is in the same package, it can access protected members. It's very lame. And that's why nobody uses it. Does internal do that? I'm not a huge... Let me look at this. Okay. So if I said protected int I and then protected, or no, not protected, but internal int A, I'll call these A and B. So since the let's say camera controller and the orbit component are in the same package, this should be able to access. It's fair to say camera controller component C is equal to null, whatever, who cares. I should be able to say .b. Okay, so you can, but you can't say .a. Yeah, okay, that's exactly how it works in Java. Yeah, Java, I guess internal is basically like protected in Java. It's so lame. I hate it so much. But yeah, I wasn't aware of internal. I thought I thought it had to do with something with C, but maybe, no, because C# isn't based on C, it's based on Java anyway. I don't know. C# is just the better version of Java. That's what I've seen. But yeah, that's part of it. Yeah, basically it's the same thing in Java. You very, very rarely use protected in Java because it's so useless. You usually want something to be either private or, usually I want to use protected, but, in C# I like to use protected a lot just because it lets you, it fits with object orientation, open to extension, closed for modification. But the problem with private is that it closes things to extension, right? So you don't get the same level of extensibility that you normally get. And so that's why people in Java use getters and setters just way too much. they automatically create a getter and setter for everything, and it's just so terrible. But I mean, plus in C#, if I wanted to, like if I wanted to make this, yeah, if I wanted, but also if I wanted to make this, the other reason that I like to use public a lot is because, if I wanted to make this zoom speed like protected, you know, I could, or make it, you know, read only or something, I could just do get, you know, protected set, you know, and it's perfectly fine with that, and just all of the compiler references will evaluate correctly. And I wish Java had something like this. It just makes me so mad that Java doesn't. Like, I like some of the stuff about Java, like the enum stuff in Java is amazing, but the that's one thing I miss with C# is that you don't get the crazy enums. But yeah, what I need to say is if input.getAccess, I'm gonna get this done eventually. What I need to do is I need to get, oh, it's not this, it's in Unity. Nope, not that, in Unity. Isn't there's an axis, and it's, yeah, mouse scroll wheel. So var input equals input get axis. It should be mouse scroll wheel. If input not equal to 0, then what we would need to do is we need to say that the camera dot orthographic size is equal to or equals the input times the zoom speed plus equal to input times the zoom speed, which by default should be 1. Why does it not like that? Cannot convert both. Oh. Wait. Where did I put the... Oh, not orthographic. Orthographic size. Orthographic size. Yeah, there we go. Actually, there's literally no point. I just might as well. Like, sure, it's not optimal, but who cares, actually? It doesn't matter. Times zoom speed times time.delta time. Yeah, there we go. Okay. I think that'll do zooming. Nope, I don't want to show this. I need to hide my desktop. Why does that not work? What did I do wrong? Oh, I know why. Because I've gone into Unity multiple times and the default here is 0. Wait, no, it isn't. Do I need to increase the speed? The camera zoom level is set to 0. What did I do? Oh, unassigned reference. Oh, right, because I'm not... Oh, God. My brain is so thrown off right now. The problem is that I didn't actually assign the camera. And I am actually getting hungry. So where is... Oh, right, because the camera's not here. Right. I remember. It's down here. Okay. Where is it? It is here. Yes. Okay. And it still doesn't work. Zoom level's correct, though. But I'm not actually getting the axis. Why? Camera.orthographic size, private void update. It's a Unity message. It says 0 references. That's equal to input.getAccess. Did I misspell something? No, it is definitely the mouse scroll wheel. guess what I can do... scroll wheel, yeah, that's correct. Times zoom speed times time to delta time. You can do a get and a set, okay. Let's see, set projection matrix, no. No, really, that should be working, should it not? Am I crazy? It's assigned in here. Zoom level is read correctly. Zoom speed is read correctly. But I am not getting zoom in and zoom out. If I set that to 50? Oh, it's too low, that's the problem. Okay, that's fair. And I want that to go the other way. So yeah, the zoom speed should probably be, I'm actually curious why, hang on, times zoom speed, so it should be, I don't know, I'm not going to mess with it. Let's just say 100, that's probably fine. Alright, yeah, that smoother. 500? I don't know why that has to be so high. Cause like, shouldn't that be 5 units per second? Yeah, okay. Alright, my brain is completely melted, so I'm going to call it here for today. It is about 1:45, so I will be back here at 2 Central, that is. Yeah, 2 Central, and we'll be doing some Valheim stuff for like 2 hours. And then tomorrow I will be back here at 11 Central for some more programming whenever I have some more ideas for this, and I've thought through some things a little bit more, and my brain is rested. Anyway, thank you guys for watching, and I will see you in a little bit.